Hi, today we will discuss about Bose Einstein condensations. In what Bose Einstein condensations is actually mean. So to explain this phenomena, we first know about Bose Einstein statistics, that is known as BE statistics. This is mainly based on two assumptions: that particles are indistinguishable and they do not obey Pauli exclusions principle. They do not obey Pauli exclusions principle. And if we follow that statistics and want to know the distributions functions, that is Bose Einstein distribution functions, this is like is 1 by e to the power alpha plus beta ei minus 1, where alpha is minus mu by kt, where mu is chemical potential and beta is 1 by kt, and k is obviously Boltzmann constant. So this is the distributions functions API for BE statistics. So distributions function is API, that is 1 by e to the power alpha plus beta ei minus 1. This actually is nothing but Ni by Gi. What is Ni? Ni is the number of particles in ith state. What is Gi? Gi is degeneracy of ith state. And Ni is the number of particles. To explain the Bose-Einstein condensation, we first emphasize on this fact, these distributions functions. So we rewrite these distribution functions. That is Ni by Gi equals to 1 by e to the power alpha plus beta ei minus 1. So Ni is Gi by e to the power alpha plus beta ei minus 1. If we want to calculate the total number of particles, we just sum over this. So N is sum over Ni, that is Gi e to the power alpha plus beta ei minus 1. This is the total number of particles. If we convert into integral form, 0 to infinity Ge dE by e to the power alpha plus beta ei minus 1. It is integral form. We want to calculate the total number of particles N. So N is 0 to infinity Ge dE by e to the power e minus mu beta minus 1. Putting the value of alpha equals to minus mu by kt and beta equals to beta alpha. Put the value of alpha, we gets this equation in the form like this. We know Ge is the degeneracy and Ge represent density of states. Ge represent density of states. So if in 3D case, what is density of state? For this In my previous lecture, I explained what is density of state. GED. In 3D case, we calculate GEDE 2 pi v by h cube 2m to the power 3 by 2 e to the power half dE. If we put the value in these equations, if we put the value of GED in this equation, this equations reduces to n 0 to infinity, the constant term 2 pi v by h cube 2m to the power 3 by 2 0 to infinity e to the power half dE by e to the power e minus mu beta minus 1. These equations, the form of the equations reduces in this form. So n is 2 pi v by h cube 2m to the power 3 by 2 0 to infinity. We divided numerator and denominator by this term e to the power e minus mu by beta. So e to the power half by e to the power e minus mu beta by into 1 by divided 1 minus e to the power minus beta e minus mu dE. This equations looks like this. So n equals to 2 pi v by h cube 2m to the power 3 by 2 0 to infinity e to the power half e to the power e minus mu beta, and this term we express this term something different. We express this term to the exponential series L running from 0 to infinity e to the power minus beta e minus mu into L dE. Look at this. If we put the value L0, this first term, if we put the value 1, this second term, third, fourth, so we express this term in this form. We express this term in this form, L running from 0 to infinity e to the power minus beta e minus mu into L dE. So L running from 0 to infinity. If we put the value L0, you get first term. If you put the value L1, second. If you put L2, so this series actually of first term 1 and a arithmetic progressions, that is minus beta e minus u. So we express this term in this form. So n 2 pi v by h cube 2m to the power 3 by 2 0 to infinity e to the power half. We insert this term in these equations. We insert this term in the equation. Therefore, this L e to the power minus beta e minus mu into e to the power minus beta e minus mu into L dE. So if we put the value L0, this term exists. So L running from 1 to infinity. So L running from 1 to infinity, L0. L 0 to infinity, this looks like this, e to the power minus beta e minus mu into L dE. If we put the value L0, this term is 1, but this term exists. So we can write it as 2 pi v by h cube 2m to the power 3 by 2 0 to infinity e to the power half sum over L0 to infinity, sum over L0 to infinity, sum over L running from 1 to infinity into e to the power minus beta e minus mu into L. Why we change the limit of L? Because if we put the value L0, then this term is exist. So in this series, for the first term is e to the power minus beta e minus mu. So if we put the value L1, so the series starts from the value L1. So we write in this form. So n equals to 2 pi v by h cube 2m to the power 3 by 2, 0 to infinity e to the power half. We simply multiply these two terms, e to the power minus beta el into e to the power beta l mu de. This term is constant term 2 pi v by h cube 2m to the power 3 by 2, 0 to infinity e to the power half. The constant part is L running from 1 to infinity e to the power beta L mu. This is the constant part. We bring it beside the integrations. So 0 to infinity e to the power half, and this e to the power minus beta Le de. So this is 2 pi v by h cube 2m to the power 3 by 2, L running from 1 to infinity e to the power beta L mu. This integration is gamma 3 by 2 by beta L to the power 3 by 2. So what is the value of n? That n is 2 pi v by h cube 2m to the power 3 by 2, L running from 1 to infinity to the power beta L mu by, here the L is L to the power 3 by 2. We insert this L into this L to the power 3 by 2 and gamma 3 by 2 1 by beta 3 by 2. So n is 2 pi v by h cube 2m to the power 3 by 2. Here L1 to infinity e to the power beta L mu L to the power 3 by 2. Gamma 3 by 2 means half root pi, and beta, that is 1 by kt whole to the power 3 by 2. So the n, number of particles, n, 2 pi, 2 and 2 cancel out, so v by h cube 2m pi whole to the power 3 by 2, 2m pi whole to the power 3 by 2, 1 by beta is 1 by kt, so this is kt, so 2m pi kt, actually this is kt, sorry, this is kt to the power 3 by 2, 1 by beta, beta is 1 by kt, so 1 by beta is kt, kt to the power 3 by 2, so v by h cube 3 by 2, and this term also exists, L1 to infinity e to the power beta L mu by L to the power 3 by 2, L to the power 3 by 2, beta L mu by L to the power 3 by 2. So n is v by h cube 2m pi kt whole to the power 3 by 2. If we now consider the case, this is the total number of particles. This is the total number of particles n, that is v by h cube 2m pi kt whole to the power 3 by 2, and this term. For maximum number of particles, for n max, this quantity will be maximum. For n max, mu is 0. Mu যদি 0 হয় তাহলে n max হবে, so n v by h cube 2 pi mkt whole to the power 3 by 2, this L running from 1 to infinity 1 by L to the power 3 by 2, this is v by h cube 2 pi mkt whole to the power 3 by 2, and this is Riemann zeta function 3 by 2. This is Riemann zeta function 3 by 2. So n actually, n number of particles in max v by h cube 2 pi mkt whole to the power 3 by 2, and zeta 3 by 2 is a value of 2.612. 2.612. So this is the value of n max. If we carefully look the above situations, if we carefully notice the above situation, when we start our derivations, we simply assume that n is total number of particles present. N is total number of particles, and from these derivations, from first of all we start our derivations at this point, 2 pi v by h cube 2m to the power 3 by 2 0 to infinity e to the power half e to the power alpha plus beta ei minus 1 b, something like that. We start our derivations from this point. Here we consider n is the total number of particles, but for ground state, if we put the value e0, n equals to 0. This integration totally we cannot integrate this, so n is 0. For ground state, if we put the value e0, then the integrations not possible, so n 0. So here n is actually denotes the total number of particles in excited state. So n actually denotes total number of particles in excited state, but we all know that there may be a possibility that ground state particles may also be in ground state. So this not the total number of particles, this is the number of particles in excited state, because if we put the value e0 for ground state e0, this integration is not possible, so n0. But there is a certain possibility that there may be particle may exist in the ground state. So we not calculate total number of particles, we calculate number of particles in excited state. So number of particles in excited state is this value. If this limit crosses, then the particles, so we also notice one thing, capital N total number of particles, Ng, that is the number of particles in ground state, number of particles in excited state. We actually calculate the number of particles in excited state, this value. If this value exceeds, then the particles move towards ground state and accumulate lower energy levels. This is Bose Einstein condensation. It is not the condensation, ordinary condensations like vapor, steam or etc. It's like a pure quantum mechanical effect. If this value, total number of particles in excited state given by this value, if this value exceeds, then the particle move towards ground state and accumulate lower energy level, that is ground state. This is called Bose Einstein condensations. So this is if the total number of particles in excited state, this quantity if it exceeds its limit, then the particles moves towards ground state. This is called Bose Einstein condensation, and the particles will accumulate lower energy levels, accumulate lower energy state. This is called Bose Einstein condensation. From this, one question arises: is Bose Einstein condensation occur for 2D bosons gas? If Bose Einstein condensation occur for 2D bosons gas, one question arises: for 3D, we calculate it for 3D gas because we consider GED for 3D case. So we calculate the total number of particles V by H cube 2 pi mkt whole to the power 3 by 2 into 2.612. This is actually 3D case. So one question may arise: if Bose Einstein condensation occur for 2D bosons gas. So one question arises: if Bose Einstein condensation occur for 2D bosons gas, is Bose Einstein condensation occur for 2D bosons gas? Let us check. N 2 pi V by H cube 2m to the power, no, N is simply 0 to infinity GEDE and e to the power E minus mu beta minus 1. For 2D gas, for 2D, GED is something like that: 2 pi ma by H square, 2 pi ma by H square, 2 pi ma by H square, 2 pi ma by H square into 0 to infinity 1 by e to the power E minus mu beta minus 1 dE. So same procedure, 2 pi m by ma by H square into dE, simply. So if we put the value GEDE here, so we get N 2 pi ma by H square 0 to infinity E minus mu beta minus 1 dE. Same procedure repeated. Divided numerator and denominator by this term. So e to the power E minus mu beta 1 minus e to the power minus beta E minus mu dE, and represent this term in this form: n equals to 2 pi ma H square 0 to infinity 1 by e to the power E minus mu beta, and express this term is like this: L running from 0 to infinity e to the power minus beta E minus mu L dE. If we insert this term in this form, if we insert this term in this form, so this is 2 pi ma by H square 0 to infinity L running from 1 to infinity e to the power minus beta E minus mu L dE. So n equals to 2 pi ma by H square 0 to infinity. We simply multiply this term e to the power minus beta E L e to the power beta L u dE. This is the constant term. So 2 pi ma by H square 0 to infinity, constant term L1 to infinity to the power beta Lu, 0 to infinity to the power minus beta Le dE. So n is 2 pi ma by h square, L running from 1 to infinity e to the power beta L mu, and this quantity is gamma 1 by beta 1 by beta L whole beta L মানে kt. So this quantity, actually if we insert the value L here, so 2 pi mkt a by h square L1 to infinity to the power beta Lu by L. For maximum value of L, for maximum value nex mu 0 hote hobe. For maximum value mu must be 0, so 2 pi mkt a by h square, L running from 1 to infinity 1 by L, so 2 pi mkt a by h square, that is zeta 1, which is the value of infinity. So in the excited state there is a possibility of infinite number of particles. So if in excited state infinite number of particles are may if in the excited state infinite number of particles are possible, so Bose Einstein condensation cannot occur because there is a possibility of infinite number of particles. So there will be no possibility, or there will be no tendency of particles to move towards ground state or accumulate lower energy level. So Bose Einstein condensation is not occur for 2D boson gas, because in the excited state there is a infinite number of particles. Thank you for watching my lecture. Please subscribe the channel.